Okay, so this screen recording is going to be about the VSEPR theory when you have 5 electron groups around the central atom. So one thing that we have, so I will say when we have 5 electron groups, the base shape for that is a trigonal bipyramid. And the way I draw it, so, here is my central atom. And I'm going to go ahead and draw the trigonal part. So it's got kind of a trigonal planar part. So there's one bond that comes out here, and then I'm going to use this wedge to represent something coming out at you, and a dash to go behind, and then we have a line up here and a line up here. So essentially, and I'll put little dots where all the atoms would be. So this is a trigonal bipyramid. And we have the central atom here, right? 5 groups. And in this case, I've drawn them all as bonds. So this would be something with 5 bonds. And essentially, right, I have 3, 1, 2, 3 here. They make up, it's a planar triangular shape, so trigonal planar shape here. And then I have one that's kind of coming up on the axis and one down, and you can kind of see that there's sort of a T shape, and these are in the plane. Now, to go ahead and show you what this looks like, I have the PhET animation here from, it's from the University of Colorado. And what I've done here, and I'll just go ahead and use my pointer, right? You can kind of see down here, we have the molecule geometry and the electron geometry. So the electron geometry is based on the number of groups, right? So in this case, I have 5 electron groups, like I said. Here, they all happen to be bonds. The molecule geometry is what the actual shape is. So in this case, they're both the same. There are 5 bonds, right? So that's 5 electron groups, trigonal bipyramid. And since they're 5 bonds to other atoms, the actual molecular shape is a trigonal bipyramid as well. And I've also checked it over here so that you can see the bond angles. Okay, so going ahead and doing this, right, I'm just going to go ahead and make it so that I can rotate this around. So you can kind of see here, right, this is how I've drawn it. I've got one coming out at you, right? So this one over here would be this one over here with the wedge. This one going out behind would be this one over here that I've drawn a little bit more dashed. And then, right, these 3 I've drawn in the same plane, right? Those are in the plane of my iPad. So I'm just going to rotate this around a little bit for you. And you can see here, right? So this is there. And you can see if I rotate it this way, and let me try to get it so that you can see the trigonal plane, right? So this is the part where you can kind of see that there really are indeed, right? So these 3 things here, these 3 bonds, right? These are the thing here. So there are 2 different kinds of bond angles in this trigonal bipyramid. There are 120-degree bond angles, and there's also 90-degree bond angles. And I'm going to just rotate it around a little bit more so that you can kind of see that as I rotate. Right, so there are some 90-degree bond angles that you can see, and then you can also see those 120 are there. And this is going to be important because the next thing we're going to do is figure out what happens if one of these bonds is not a bond anymore, but it becomes a lone pair of electron. So I'm just going to kind of go ahead and notate the shape, the bond angles in here. So in this trigonal plane here, these are 120 degrees, and up here, they are 90 degrees. Okay, so one thing that we need to know when we think about going from 5 bonds to still 5 electron groups, but we want to think about what happens when there are 4 bonds and 1 lone pair. One thing that we want to know is that the lone pairs, right, want as much space, right, as possible. Right, so the bonding electrons are held between 2 nuclei. They're a little more confined. The lone pair is really only held by 1 atom, and so they tend to be a little more expansive, and they want as much space as possible. So when I think about how to go from 5 bonds to 4 bonds in a lone pair, I have to think about which position is going to give me the most space. And in this trigonal bipyramid, there are 2 different kinds of spaces. So I will argue that there are positions, and I'm going to do these in blue. These blue ones, right, are the 90 degrees. And there's a separate kind of position over here with sort of these green ones that are in the triangular planes that are 120 degrees apart from each other. So the blue ones are 90 degrees from another electron group, right? The green ones are more 120 degrees from an electron group apart from each other. And so thinking about what's farther apart, it's actually the 120 degree one. So we got to keep that in mind, and that's going to be sort of a guiding principle, is essentially as we take bonds away and instead put in lone pairs and think about what those shapes would be, we have to go by this guiding principle that those lone pairs want as much space as possible. So we're always going to put them in the position where they have the most space. Okay, so I think what I'm going to do is go ahead and actually I'm going to go here and I'm going to give myself a duplicate slide. Okay, so I can say done. I can go here. And I'm going to erase what's here, and we're going to think about still 5 electron groups, right? And instead of having the 5 bonds, we're going to have, and let me make sure I have white pen, right? We're still going to have 5 electron groups total, but this time we're going to have 4 bonds, right? And 1 lone pair. And as I mentioned in the last slide, the lone pair wants to be in a position where it is as far away. And so it's going to be on one of those positions where the bond angle is 120 degrees rather than the 90 degree position. So here's my central atom. And I'm going to go ahead and put the lone pair here, right? One of those 120 degree positions. I'll put one of the 90 degree positions, the other 90 degree, and then I'll go ahead and make a wedge out here and a little dash right back here. So that's what it's going to look like with 4 bonds and 1 lone pair. And I'm going to go ahead and see if I can get the PhET site to load. Here it goes. We go to models. So I've got 2 bonds, 3 bonds, 4 bonds, and a lone pair. And I'll click the boxes so that we can see the molecule, we can see the electron geometry, and we can see our bond angles. Okay, so as you can see, the electron geometry, because there are still 5 groups, right? 4 bonds, 1 lone pair, that adds up to 5. The electron geometry, the base shape is still going to be a trigonal bipyramid. So it's still based on a trigonal bipyramid, but the actual shape of this molecule, we call it seesaw. So this one is going to be a seesaw, right? Or people also call this a distorted tetrahedral. That's the other name for it. So again, in this one, and I'm just going to go ahead and rotate it around up here so people can see it. So I just have to click it till that turns blue. You know, why is it called a seesaw? Well, it kind of looks like a seesaw. So, you know, you could imagine, right, a seesaw. Right here is a person could be sitting here, another person could be sitting here, right here, sort of the little fulcrum where it would go back and forth. And so that's why it gets the name seesaw shaped. Up here is my lone pair of electrons, right? So you can imagine person sitting here, person sitting there, and going back and forth like a seesaw. So not a super original name, but it gets that name because of the shape. But, you know, you can see there's still 120 degrees between the ones that are sort of making the base of the seesaw. The people would be sitting on the 90 degree one. And so this is the seesaw shaped. Okay. All right, so what happens if we go ahead, I'm just going to go ahead and erase what I've got here, right? So what happens if I take one more off? Where am I going to take it? Well, I still have a choice between 90 degree, right? So I still have things over here, and let me kind of arrange them there, right? I still have a 90 degree position if I'm going to remove one of these bonds and add another lone pair, right? Which bond do I take off? Still have a choice between 90 and 120 degrees. Again, that lone pair that's going to go on is wanting as much space as possible. So when I take the next one off and I now have 2 lone pairs and 3 bonds, I'm still going to take away one of these positions over here. So let me go ahead and I'm going to go ahead and erase what I've got here, and we'll make a little note of that. Okay, so I'm still going to have 5 total electron groups, but this time I'm doing 3 bonds, right, and 2 lone pairs, right? So still 5 total. So I will go ahead and I'm going to get it up here in my model. So I'm going to delete one of the bonds and I'm going to add another lone pair. Okay. And you can kind of see what's happening up here, thinking about that, what it will look like down here when I draw it, right? Here's my central atom. I'm going to put a lone pair here. I'm going to go ahead and put a lone pair. Maybe I'll just make this sort of like thicker right here, right, I will still have a dotted one up here, right? I still have something up here at 90 degrees and something up here. And this molecule is going to be what we call T-shaped. And again, it looks like a T. That's why it's called the T shape. So, you know, here you can see it looks like a T. So basically 3 atoms, they actually will be in the same plane. So I'm going to go ahead and rotate that around so you can see that, but you can kind of see that they are nice and planar, right? As I rotate that around, those the T-shaped, the bonds are in the same one. And then I've got the lone pairs as far apart from each other on those 90 degrees. Right, I've got one lone pair out here, one lone pair out here. Putting them in the 90 degree, then 120 degree position gives them as much space as possible. So these are there, right? The bond angles are 90 degrees. So I have the molecule looks T-shaped. That's its molecular geometry. That's its molecular shape, right? But it is still based on, right, the electron geometry. The base shape is a trigonal bipyramid. Okay, and so at this point, I'm going to just go ahead and do the last one. And so again, it's the same principle going from this T-shaped, and I think about which of these 3 bonds, right, where am I going to give the most space to a lone pair? Would it be in one of these positions sort of on this axis, or would it be this one? And you can probably see that, like, if I put the lone pair you know, here it'll have the most space and put the bonds as far apart from each other. So the last one, and I'm just going to go ahead and I will make the shape up here in the FET so you can see it. So I'll remove a bond. First I got to click in the right spot. Remove a bond, put in an extra lone pair, and you can kind of see what's going to happen, right? Those lone pairs are going to arrange themselves, right, around where the they're going to arrange themselves 120 degrees, and now I've got a linear molecule. So I'm going to go ahead and write that. So I'm going to erase what I had here, right, and go ahead and put my pen. So what happens when we have 2 bonds, right, and 3 lone pairs, right? We're going to end up with, right, a linear molecule. It's going to look something like this, and I'm going to have a lone pair here, and I'll try to do this sort of bold, a lone pair here, and maybe, right, a lone pair back there. That's what it's going to look like. So I'm going to go ahead and draw the molecule up here. In fact, oh, it remembered it. Perfect. So again, that's what it looks like. So this is going to be linear when I go ahead and do that. So you can see there. But again, the whole principle, the whole organizing principle is putting those lone pairs where they'll have as much space as possible. So you know that it's got, right, 5 electron groups. The base shape is that trigonal bipyramid. And then you think about, okay, if they were bonds, they'd be a trigonal bipyramid. And then just start, basically, if you're doing this with your model kit at home, start pulling away those bonds and thinking that, okay, that space now has a lone pair in it. But pull away the bonds in the space that they will have, the most space as possible, and that's along that, right, the trigonal planar part of the trigonal bipyramid. And that's the end of this video.